Does sliding up the front foot really lift the board higher? If so, why can you not lift your board by doing so? And in the first place, what makes it hard to raise the front foot? In this video, we'll see the scientific functions of the front foot and how to use it effectively. First, let's look at the forces that act on the board. When you pop the tail, the board rebounds off the ground. At that moment, two things happen. The board's center of mass rises, and the nose lifts, increasing the board's angle. The key is how to maximize and control these forces. Let's consider what happens in a low ollie. Even with a light pop, the force that lifts the nose causes the board to flip over if there is nothing that stops it. As the front foot rises together with the board, it controls the board's rotation and prevents the nose from rotating too far. In this process, the front foot does not actively push against the nose. It's the nose that pushes the front foot in. Look at the position of the knee. It's farther forward than the nose. Without the board, the front foot hangs straight down. But if you put it back, because of the force of the nose to rise, the front foot is pushed back. And without even thinking about it, because the front foot tries to go back to the neutral position, it causes a gentle push against the board. As that happens, the force of the nose to rise is gradually used up. Soon after that, the upward energy of the board fades away, and the board starts to descend. So, in a low ollie, the front foot is just passively pushed back by the nose and doesn't really do anything to get an ollie higher. Now, let's consider a high ollie where things change. Popping the tail harder increases both the upward force on the board and the force that raises the nose. Because the upward force on the board is greater, even if we consider the rebound from the ground alone, the board rises higher compared to when popped more weakly. While we can expect that the stronger rising force on the nose creates considerable friction between the nose and the front foot. The question is, what does the front foot do? Does it raise the board by using that friction? Or, like some people say, does it just block the nose from rotating too far? And in light of the vertical movement, it just rises with the board without increasing its momentum. Does it make sense? In other words, does the front foot proactively raise the board? Or does it just not get in the way of the board rising? Let's run an experiment. To recreate the situation where the deck presses against the front foot, I attached the metal parts to the deck, and the rod was passed through it. A hook is attached to the end of the rod, and a rubber band connects it to the wall. Let's try a weak rubber band. As expected, the friction between the board and the shoe is not very strong, and the board simply doesn't lift at all. Now let's make the contracting force stronger. As the shoe is lifted, you can see that the board rises with it. At first glance, this seems to suggest that strong friction allows the front foot to lift the board. You might have already noticed, however, that this experiment has a major flaw. The friction is always constant. In a real ollie, the force of the nose to rise should gradually decrease. So let's try another experiment. This time, the tail is popped and a shoe is slid up so the nose loses its energy. Compared to holding a shoe at a fixed height, sliding it up actually causes the board to rise higher. As you can see, after making first contact, the front foot slides up the board and guides it to rise higher. And compared to a case without a shoe, the board reaches slightly higher. At least it gives the board some time in the air. So what can we say from these experiments? Although the front foot can actually increase the board's upward momentum, its contribution to the height is only a small part of the total height. Most of the height comes from the rebound of the ground. The front foot can only enhance it to a limited extent. In fact, the importance of the front foot is quite the opposite. It causes a huge impact when it fails to slide up high enough. Imagine a board has upward momentum and collides into an obstacle. When they are aligned, it seems natural that the board's center of mass loses some of its momentum. Now, what if the obstacle slides to the side? Intuitively, it seems like the board's center of mass rises without being affected by the obstacle, but that is not the case. From a physics perspective, no matter where the object is, when it hits the board, the amount of force the board loses is constant. Meaning, when an object sits in the center and the board collides with it, it surely loses its momentum. But when the object sits above the nose and stops it from rising, the board loses exactly the same amount of momentum. I just use the term sitting, but the front foot is not actually completely stationary. In reality, everyone naturally tries to lift the front foot. The problem occurs when the lift of the front foot is either too slow or stops halfway through the motion. It helps to think of the board and the front foot as moving independently. In a common mistake, the front foot desperately tries to rise but is too slow, while the board continues rising with its initial momentum. If you picture them together, you can see that although the front foot is rising, the board pushes it upward even harder. As a result, the front foot interferes with the board's upward movement. It's the nose that collides with the front foot, not its center of mass. However, because of the mechanism just explained, some of the energy that would otherwise lift the board is dissipated. If the front foot interfering with the board and consuming its upward momentum is the source of the problem, lifting it high enough so it won't interfere with the board is the only way to solve that problem. Thus, although the experiment did indeed show that lifting the front foot allows the board to rise higher, that is not the primary reason beginners should focus on lifting it. Rather, they should do so to prevent the front foot from interfering with the board and losing the upward energy it needs to continue rising. So, what should you do? Should you just lift your front foot as high as possible? No. There is a range within which you can move your front foot due to the structure of the human body. You can't lift your front foot because you're trying to lift it beyond that range. The key is to connect actions together. If the front foot can move only within the range, why not lift your body and bring the range itself higher? Instead of sticking to the height of your front foot alone, create a situation where you can lift your front foot higher without difficulty. And to do that, you need to raise your center of mass first. Doing so not only allows you to lift your front foot higher, but it also allows you to pop harder. If you think about it, lifting something means pushing something down. As you raise your center of mass, it becomes easier to use the reaction to pop the tail harder. So in summary, by lifting your center of mass, you can raise your front foot higher, and the back foot can pop harder. All these are connected. Don't stick to the idea of lifting the front foot alone, because physically and physiologically, it doesn't work that way. Let's also see a bad example. If you try to pop using only your leg muscles while your body weight stays low, everything starts to fall apart. Because the front foot stays low, it blocks the nose as it tries to rise, and the board's upward energy is consumed for nothing. Popping without lifting your front foot high enough is virtually the same as pressing your front foot back with the force of your back foot. Just like you can't gain momentum by pushing yourself, it doesn't mean anything. Your front foot absorbs the force you generated by popping the tail so hard, and it does nothing. Plus, since your center mass did not rise, you will immediately start to fall, once you reach the peak of your Ollie. It's just like when you hold an object in your hand, then moving your hand away. It's not supported by anything, or going upward, so there is nothing it can do but fall. As your body senses that it is falling, your legs naturally begin to extend. This happens because landing with bent legs is like embracing all the force instantaneously. Whereas extending your legs allows you to absorb the impact more gradually, which is more natural. So all these problems happen by trying to pop only with the leg muscles. Pop is a result of extending your body, not something that works all by itself. And if you extend your body, not only can you pop harder, but you can also raise your front foot higher, which is essential to avoid wasting the energy of the board. Lastly, the angle of the knee is also important. When people jump in general, their knees usually point toward the front of their body. If your knee points completely to the front in your Ollie, you have to lift your front foot at exactly the same speed as your board does. But when you want to lift your front foot as high as possible, it can easily move faster than your board and loses contact with it, which makes it harder to control. Opening your knee solves this problem. By doing so, even if you lift your knee at the same speed as when your front foot loses contact with your board when your knee is closed, your front foot always stays in contact with your board as it tries to go back to the neutral position by itself. When your knee is closed, however, your muscles don't have any tension to go back to anywhere. Open your knee and all you have to focus on will be the vertical lift. The structure of the human body will take care of the rest. And that's all for this episode. Thank you so much for watching. Until next time.